Okay guys, we are back now with Learning Target 2A solving equations, and this time we're talking about special cases. Okay, so remember, a solution, right, or answer is what makes the equation true, right? When we plug it back in and we do all our math to it, it ends up with a true statement, right? So we need to ask ourselves, what if the result is always true? And what if the result is never true? Okay, so here we're going to look at 3 examples here and see what happens when we arrive at certain things. Okay, so to solve, we are going to ski. So the first thing we're going to do is simplify by distributing and combining like terms. Okay, so here I'm going to distribute this negative. Okay, it's technically a -1. Okay, so here I have 5. Negative 1 times 3x gives me a negative 3x, and a negative 1 times 4 gives me a negative 4. Okay, equals 1. Then, continuing with s in ski to simplify, I'm now going to combine like terms. So 5 here and negative 4 are like terms. They are both constants. Okay, constants is when you just have the number. Okay, no variable, no letter attached. So 5 minus 4 is 1. So 1 minus 3x equals 1. Okay. After that, if there were variables on both sides, I would move it all over to the same side, but the variable's all on the same side. So all I have to do now is isolate x. Okay, so I'm going to subtract 1. Okay, this cancels, leaving me with negative 3x equals 1 minus 1 is 0. Right? Or in one way to think about it, it canceled, so that's why it's 0. Okay, then get rid of that negative 3. Let's divide by negative 3. Okay, x equals 0 divided by any number is 0. So my answer here is x equals 0. Okay, and that's our only answer. Okay, it's the only number that when we plug it back in will be a true statement. Okay, so let's look at the next one. Okay, so we're going to solve, again, we're skiing. Okay, so the first thing we're going to do is simplify, okay, by distributing or combining like terms. There is no distribution, there's no parentheses, right, where we have to distribute and multiply something, but I do see like terms, okay? On the left side, the like terms I see are 11 and negative 7, right? Those are both constants. And on the right side, the like terms that I see are 6x and negative 3x. Okay, so again, when we're solving, especially if we know that we're going to get things mixed up or accidentally lose something, I draw that line straight through so we know what's on what side. And when we're combining, we can only combine what is on the same side. Okay, so 11 minus 7 is 4, so then it's 3x plus 4. Right, so the 4 came from the 11 minus 7. Okay, and then 6x minus 3x gives me 3x. So 3x plus 5. Okay. Okay, so that's S, simplify. Combine like terms, distribute. Next is K, right? When we have variables on both sides, we need to kill it off. Okay, so we move it to one side. So I'm going to move this one over. Okay, so I'm going to subtract 3x. What I end up noticing is this cancels to be 0, so then it's just 0 plus 4, so that's 4. And then on the right side, it also cancels, right? So to 0 plus 5, and I get 4 equals 5. But wait a minute, 4 equals 5 is not true. It will never be true. 4 is never 5. And so when we arrive at something like this, that is clearly not true, the answer is no solution. Okay. And the reason why is because 4 equals 5 is a false statement. It is not true. It will never be true. It's a false statement. Okay? And what that means is no matter what I choose, no matter what I plug into x, nothing will make this equation true. Nothing in the end will make 4 equal to 5. Okay, so that means my answer is no solution because I arrived at a false statement. Okay, So whenever you're solving and you arrive at something like this, that is clearly not true, the answer is no solution. No matter what you plug in for your variable, it's not going to change. It's never going to be true. There is nothing, no solution. Okay, so here, let's look at the last one. Okay, so we're skiing, right, to solve. So the first thing we're going to do is simplify, okay, by distributing and combining like terms. Okay, so I'm going to distribute this negative 2 by multiplying. Okay, so negative 2 times x is negative 2x. Okay, and negative 2 times 3 is negative 6. Okay, again, remember, be careful of those signs. Make sure you are multiplying correctly. Okay, then I'm going to combine like terms. So the like terms I notice on the left side is 6 and negative 6. And what ends up happening is 6 minus 6 is 0. So all I'm left with on the left side is negative 2x. And all I have on the right side is negative 2x. This is always true. Negative 2x is always going to equal negative 2x. And so what that means is I have infinitely many solutions. Okay? But to be even more specific, it's because my answer, my solutions, is all real numbers. Okay? And we normally write that with the special R. And the reason why is because negative 2x will always equal negative 2x. Right? And this means that whatever I choose to plug in for x here, it will always be true, right? If I choose to plug in 3 for x, it's still going to be true, right? Because then that'll be negative 6 equals negative 6, right? I could choose to plug in 1,000, right, in for x, and that'll still be true, because if I plugged it in, that'll be negative 2,000 equals negative 2,000. That is always true. No matter what crazy number you plug in here for x, this equation is going to be true. So my answer, when you arrive at something like this, that is always true, like x equals x, 4 equals x equals 4x, or 5 equals 5. When you arrive at something like that, this is technically known as an identity, right? And your answer will be all real numbers. Okay, so that's it for special cases. Okay, see you next time, guys.